by revising the previous lesson. The previous lesson was about the location of Africa. Yes? Do you remember?
Yes.
Yes.
Okay. About Africa. When we talk about Africa, we have seen the relative location of Africa, the absolute location of Africa, and also the facts, the geographic facts about Africa or continent, yes? Do you guys remember all these things?
Yes.
Yes.
So to revise the important point, Africa, we said Africa is the second largest and the second most populous continent. Yes, Africa is the only continent crossed by both latitude, Tropic of Cancer and Tropic of Capricorn, and also it is crossed by the equator. The north-south length is greater than the east-west width. Yes, and when we come to the absolute location of Africa, we said Africa, northern point or northern external point lies at 37 degrees 21 minutes. Yes, and the name of the place is Cape Blanc or Ras Pensaka. And at the south, it is 34 degrees and 52 minutes. And the name of the place is Cape Agulhas. In the west, it is at 17 degrees and 11 minutes. It's Cape Verde. And then in the east, at 51 and 24 minutes. And the name of the place is Cape Gaddafi. Yes, this is the absolute location of Africa with the name of the extreme point. And then when we come to the relative location, Africa is located south of, that means to the bottom of Mediterranean Sea and Europe, and north of Antarctica and the Southern Ocean, and east of Atlantic Ocean, and west of Indian Ocean. Yes, and we said Africa's total area is 30,303,606 square kilometers. Yes, these are the main points from the previous lesson. And from the today's topic, and from the today's topic is about latitudes, and from latitudes and longitudes, and from latitude and longitude. Do you know what latitude and longitude before I start my presentation?
Yes.
Okay, Julia, are you there, Julia? No, Becca? Okay, anyone to tell me what latitude and longitude is?
Latitudes are angular distance measured north and south of the equator in degrees.
Hello, is it clear? Okay, so let me start my presentation. So as you can see from the note on your screen, so the topic is latitudes and longitudes, and the first one is on what latitude and longitude is, and to explain the latitudes first. So latitudes and longitudes are essential on our globes maps to know and also to determine the climate and time. Without latitudes and longitudes, we cannot use the globe or map. If you have globe and map, that means the professional one. It has, you can see it as latitudes and longitudes. And if it has latitudes and longitudes, we can know the absolute location And we can also determine the climate type and the type. The first one is latitude and parallel. Latitudes are these angular distances. Most of you, when you say latitude, you refer to the lines, not the lines, but it is the angular distance. I'm listening some kind of disturbing voice. There is a disturbing voice. So let me present, and then if you have any question, you can ask, okay? So latitudes are these angular distances measured to the north and south of the equator, that is in degree, not the lines drawn east to west, but the lines drawn east to west or west to east, they are called parallels. They are parallels. When you see this lines of latitude or parallels on a globe, they look what? Circle, yes? They make circle. When you see this parallels on a map, they make a horizontal straight line, yes? On a globe, they are circle. On a map, they are straight horizontal line. But the purpose of these parallels or latitude on globes and maps, it's similar, it's all the same. And there are 180 parallels on, that means lines of latitude, not latitudes, but lines of latitude, because latitude is a what? Angular distance, it's an angular distance, not the line. Okay. Are you listening?
Yes.
Yes.
Oh, yes, yes.
Okay. We have 180 parallels. That means the lines drawn from east to west or west to east or making circle on a globe. They are 180. And the midpoint for them is the equator, which lies at 0 degree. That 0 degree, the equator. On a globe, the equator lies at 0 degree latitude is the longest circle, yes? But when you come to the map, it's equal to the rest of the latitudes, but it is the longest one on the globe. Even if we have 180 parallel or lines of latitude, we do not draw all of them. Why? Anyone to answer? Why we do not draw all latitudes? Have you ever seen all 180 parallels or lines of latitude on globe or map?
Because it is
No.
imaginary.
Have you?
Because it is
No.
imaginary.
Then why?
Because
It's
they are
easy.
infinity.
Only one? Yedidia, answer it. Yedidia, would you try? Okay, Becca? Brooke? Yedidia? Okay, Becca, would you try? Kedus, are you there? Kedus Gabra Selassie. Raise your hands, okay. Okay, Adonai.
Because yes, miss. Because they are infinity.
Because they are?
Infinity. We can't count them, and they are not. They're imaginary lines.
Oh, even if we do not get on the earth, we draw it on globes and maps. We do not get it on earth, yes, but We draw them on globes and maps, yes?
Yes.
The reason that we do not see them, that means we do not see or we do not draw all 180. The reason is if we draw all of these 180 parallels, then the map or the globe will be invisible, yes, or full of these lines of latitudes and longitudes, and we cannot draw the futures or the maps clearly, yes, so that we can see the futures or the places we wanted to draw. Then we do not draw or sketch the lines of latitudes. That means we do not draw all latitudes or parallels. If we have 180 parallels together with the longitudes, then the map or the globe is going to be full of verticals and horizontals, yes? Then how can we show the pictures, the futures that we want to show on that globe, yes? So we take intervals. The interval is based on the cartographer. Some cartographers can take an interval of 5, others 10, others 15, and others maybe 20 or 30. But mostly the interval we use in drawing maps and globes is 15, 15, okay? So let's get back to our presentation. Since we said we have 118 and we do not draw all of them, then we use or we have these 5 major lines of latitude. They are given with a special name. For example, the one we have at 0 degrees, the equator, it's named equator. That's the midpoint to divide the world into northern and southern equal hemispheres. Then at 23.5 degrees north latitude, we have a major latitude named Tropic of Cancer, and 23.5 degrees south, Tropic of Capricorn, 66.5 degrees north, this Arctic Circle, and in the south, 66.5 degrees, that is Antarctic Circle. Then based on this 5, don't forget we have 118. From this 118, 5 of them are major and they are given with a special name. The reason is that we divide the world into different climatic zones. So taking these 5 latitude zones, we have divided the world into 3 latitude zones, or based on the Greek classification, 3 climatic zones. So the first latitude zone, which determines the climate type, is the tropics, so low latitude. The low latitude zones are located from 0 degree equator, that means the midpoint, to 23.5 degrees north and south 23.5 degrees. Both sides, yes, 0 to 23.5 degrees north and again to the south 23.5. That is called low latitudes. That means Tropic of Cancer and Tropic of Capricorn are parts of the low latitudes. So places which are located in this low latitude zone, they have what? Hot climate. And the sun rays are vertical. They receive the vertical sun rays. Therefore, it's hot all the year round. Particularly in the equator, it is very hot throughout the year. And it's always direct for these places. Therefore, these places or places which are located in the low latitudes, that means from 0 degree to 23 degree and half north and south, the climate type is tropical, or in the other name, then torrid, tropical climatic zone or torrid climatic zone. The name of latitude zone, it's low latitude zone. Don't forget, 0 degree and 23.5 degree, both way north and south, they are what? Part of low latitudes. When you come to the second zone, it's middle latitude. In middle latitude, in the climate type, it is called temperate region, temperate climatic zone. The climate type is not too hot or too cold. It's the in between the hot and the cold. And middle latitudes are in between 23.5 degree north and 66.5 degree north and south, both ways. 23.5 degree north and south, don't forget, it's part of the low latitude. Therefore, in between 20.5 degree north and south and 66.5 degree north and south, it is a middle latitude zone. So places which are located in the middle latitude zone, they have moderate climate type. They are not too hot or too cold, which is very conducive for human life. Don't forget, 66.5 degree and also 23.5 degree is not part of middle latitude. 23.5 degree is part of low latitude, and 66.5 degree north and south is part of the high latitude. But places in between this 23.5 degree and 66.5 degree, both way north and south, they are middle latitudes, and the temperature is not too hot or too cold. It is moderate. Is it clear?
Yes.
Yes.
Am I explaining well or making some confusion?
It's clear.
Any question?
It's clear.
Okay, let's pass to the third one. The third one is the high latitude zone. In climate type, this zone has a polar climate, or the very cold one, polar zone, or it's also called frigid zone. The high latitude zone is from 66.5 degree north and south latitude to 90 degree and to 90 degree north and south. Here, 66.5 degree is part of high latitude, yes? Not part of the middle latitude, but places in between, we said earlier. So from 66 to 90 degree, that means to 90 degree North Pole to 90 degree South Pole, it is a very cold zone, and these areas receive the slanting rays of the sun. Slanting rays of the sun means the rays of the sun that travels long distances. Yes. So in this area, like when you get closer to a bulb, you get the heat and also the very high. Are you listening? When you get closer to the bulb, you see the high heat and also what? The light, yes? When you get far from the bulb, you don't feel the heat, yes? But you get the light, but the amount is less. It's the same as this sun rays. When you get closer to the equator, the area is very hot. But getting far from the equator towards the North Pole and the South Pole, the sun rays travel long distances. Therefore, the heat decreases. Am I clear? Since the sun rays travels long distances, that means the slanting rays, then heat decreases. Therefore, these areas are very cold. And when you get closer to the equator, it's low latitude zone. The sun is direct or overhead. Then there is high. Is it clear?
Yeah.
Yes.
Any confusion or question regarding these 3 points?
No.
Okay, here you have the picture with latitude zones and major latitude lines. By the way, in the North and South Pole, hello, I'm not saying some kind of disturbing voice. Please try to get away from that disturbing voice, please.
Ooh.
Okay. Still, I'm listening some disturbing voice. Please mute the speaker if there is a disturbing voice. Okay, look here. You have this world map. Can you see the bold lines, the bold ones?
Yes.
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 The bold ones are major latitude zones, yes? So here you have the equator, yes? And from equator to 23.5 degree north and 23.5 south, this is what zone? Low latitude zone. And from 23, that means in between 23 and 66, north and south, you have middle latitude. Then from 66 to 90 north, 66 to 90 south, you have which one? High latitude, yes? And the polar zone or frigid zone, you have slanting rays, so it is very cold. And here, over here, you have moderate, and this zone, very hot. At the poles, north and south pole, the length of the day and the night is equal. Therefore, they have 6 months of daylight and 6 months of darkness. That means each day, the length of the day and the night is equal, it means. Is it clear?
Yes,
No? Clear or not?
it's clear.
Okay. And that means when I say they have equal 6 months of daylight and darkness, in some days, in some months, in some countries, the day is short and the night is long. In other season, the reverse, the long day with short night. Yes. But in this area, we have equal lengths of day and night. So taking these latitudes, we can divide the latitude based on the Greek classification. Actually, we have 3 climate zones. And also there is another classification, the Köppen classification, that is 5. But for our lesson, the Greek classification, 3 latitude zones with 3 climate types is enough. Let's pass to the longitudes. Longitudes are angular distances or lines drawn from north to south.
Angular distances.
Angular distances, very good. Like latitudes were are angular distances measured north to south. They are north to south, yes. But this one east to west. But both of them are angular distances. So longitudes are angular distances measured to the east and west of the prime meridian or the equator. Or we say it's the Greenwich meridian, the 0 degree, yes. Then it joins all places with the same longitude. If places have the same longitude, they are joined by a line, that longitude, line of longitude or meridian. And when we say meridian, meridian is the line that is drawn from north to south, or north to south, south to north. Yes. So the line is meridian. The angular distance measured to the east or west is longitude. Is it clear?
Yes.
So to the line, do not refer longitude, refer meridian for the line. But for the spacing, yes, or for the angular distance, or the spacing between two meridians, that is longitude, and that is measured by a degree. Then when you see these longitudes on globe, they make what? Semicircle. Yes, they make semicircle on globe. But on map, that means on a paper, they are vertically straight, and they are equal, yes, vertically straight. But on globe, they are semicircle. Then taking the prime meridian, that means that's which is located at 0 degree, we have Eastern Hemisphere and Western Hemisphere. The prime meridian, or the Greenwich meridian, we call it the Greenwich meridian because it passes through the Greenwich Observatory in Britain. You know that, yes? In London, Britain, there is a Royal Observatory. So taking that place, they give the name Greenwich. So we call it Greenwich meridian, and that divides, or 0 degree longitude, divides the world into Eastern and Western equal hemispheres. So the distance around the Earth measures 300 degrees. That means we have 360 what? Longitudes. That is measured in degree. That is measured in degree. And then the halfway for this longitude is 180. Halfway is the anti-meridian. The halfway is the 180. This 180 degree longitude is the base of international date line. For example, if someone is at 180 degree west longitude and another person at 180 degree east, in between these two persons, there is a difference of 360, or that means 360 longitude difference. And that 360 longitude difference makes a 24 hours time difference. Therefore, the day changes. For example, if the day for the person, or Mr. X, who is in 180 east and October 14, for the person who is located at 180 degree west, the day is 1 day back. Yes, that means 13. Yes, 1-3, because there is a difference of 360 degree longitude, and that makes a 24-hour time difference. 24 hours means 1 day. Therefore, if Mr. X, for Mr. X in East 180, the October 14, for Mr. Y in 180 degree west. Is it clear?
Yes.
Okay, so 180 degree longitude is called anti-meridian, or the halfway, and also it is an international date line because day changes if you cross this 180 degree longitude. You can see here on a globe the longitude given on a globe. Here is North Pole and there is South Pole. Then you have the longitudes drawn with an interval of 15 degree, 15 degree. So this is drawn by taking an international interval for drawing longitudes, like that of the latitudes. All longitudes which are 316 degree cannot be drawn. So like the latitudes, we take an interval. It is based on the interest of the cartographer. You can divide it by interval of 5, 10, 15, 20, or 30. But the most common one is dividing the latitudes and longitudes by 15 degree interval. So from 0 to 15, there is no longitude line drawn, but we know there are 15, yes, longitudes, but they are not drawn. Is it clear? So as you can see here also, it is making a semicircle. But if you see these longitudes on a map, they are vertically straight. Am I clear?
Yes.
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 Any question?
Yes. 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 Yes.
Okay. Let me pass to traveling in time. Do you guys have a relative living outside Africa or Ethiopia? Any relative living in Europe or America or in Asia? Any relative? Is there anyone who has a relative living in Europe or America or Asia?
Yes.
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 Does that person call you during your night time or sleeping time?
Yes.
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 Okay.
Yes.
Does it mean that person is calling for you during night time in his place too?
No.
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 So why it is night for you? Why it is sleeping time for you? Why it is not for him or her? Anyone
Because the
to
time
reply?
zone is different.
Why it is different? It's correct, right answer. But why it's different? What makes it to be different from the time that you are living in?
It makes it different because it's our Earth is a globe, and
Mhm.
when Earth is a globe, so when we the sun comes in Ethiopia, it means in Europe or other places there's only moon or half a sun or sunset. But when it's night in Ethiopia, in other places it might be sunrise or sun.
Okay, good trial. But the reason is it's due to rotation, yes?
Yes.
The Earth rotates
Yes.
on its own axis. The Earth rotates on its own axis, and also it revolves around the sun. The Earth has two movements. The one is rotation and the other is revolution. Because of rotation on its own axis, day and night change, yes? This one rotation of the Earth on its own axis takes 1 day or 24 hours. Look to your globe. To rotate from west to the east, yes, that means on the face of the sun, it needs 1 day or 24 hours. Therefore, if places are located in different longitude line, the time they see the sun is different, isn't it? For example, places which are located in the eastern hemisphere, they see the sun rays first than the west. That means If it is daytime for the eastern hemisphere, that means for places which are located east of the Greenwich meridian, then it's going to be in the dark for the places which are in the western hemisphere. For example, if someone is located in London, yes, in London, which is at 0 degree longitude, is midnight. For another person or Mr. X living in 180 degree east, is the time the same? Like living in London or Japan, is the time the same? Can the time be the same? No, because
No.
if it is night for people living in London at Greenwich meridian, then the other part of the globe is having, or the earth is having, the sunlight, so it's day. Therefore, when the earth rotates from the west to the east, the easterners or the eastern hemisphere see the day and the sunlight. Then when it changes to the darkness due to rotation, then the western hemisphere see the sun, and it's going to be daytime. Am I clear? So in
Yes.
time, we mentioned Greenwich Mean Time and local mean time. The Greenwich Mean Time is the time which is calculated at 0 degree longitude, the time we have at 0 degree longitude. Yes, and the new day starts in the midnight. For example, for you, that means for us, for Ethiopians, the new day starts when? In the early morning, yes, when we see the sun rise, yes, when the sun rises in the east at 12, we see it's the beginning of the new day. But internationally, that is not. The midnight is the beginning of the new day. Am I clear? The beginning of the new day is in midnight. So taking the time at GMT, and we calculate the time from the midnight. And the local mean time is the time we have in different places. When we locate in different longitude places, then the time will be different. Yes? While it is early morning for Ethiopians, for the Japanese, it can be late evening. Yes, it's early morning for us. Then, if you call to Mr. X living in Japan, he says it's late evening because the longitudinal location is different. So taking the longitudinal location of a place, we can calculate the time of a place based on this GMT. Therefore, places which are located along a given meridian, they see the sunlight equally, whether they are living in the North Pole or South Pole. If they are on the same longitude, the time is the same. For example, 0 degree prime meridian. All people living along the prime meridian 0 degree longitude, whether they are living around the North Pole or around the equator or to the South Pole, the time is the same. They see the sunlight equally, therefore the time is equal. On the same vertical line, it means, yes? But if they are living in different longitude, the time is different, even with a difference of 1 degree. Am I explaining clear?
Yes.
Yes.
Okay.
Yes.
Therefore, don't forget. Okay.
Yes.
So don't forget, if places are located along a given, that means on a specific meridian, the time is the same because they see the sun equally. And the time, the noon time or the midnight is equal for them. But if there is a difference in any degree amount, even one, then the time will be different. Let us see the explanation, but that should be calculated next. The Earth rotates on its own axis. Then the Earth has a 360-degree longitude. Then this rotation takes 24 hours. That means if 360 of the Earth is covered by 24 hours or 1 day, yes, then if there's 1 degree, and how about 15 degrees? If 360 covered in 24 hours, then 1 degree will be covered in how many minutes or hours? Then to get the time that the Earth needs, or the 15 degree covered in time, for example, you divide this 360 by 24 hours. Then when you divide 360, that means the longitude in degree measurement is 360. Then it takes in rotation 24 hours. Then you divide this 360 by 24. Then you get how much? 15 degree. That means 15 degree of the total 360 degree of the Earth is covered in 1 hour. Yes, 360 of the Earth's area is covered in rotation by 24 hours. In 1 hour, out of 360, 15 degree is covered. And out of this 360 degree, 1 degree is covered in rotation. It means in 4 minutes. That means 1 degree of the longitude, 1 degree of the 360 needs 4 minutes to rotate on the Earth's axis. Yes? Am I clear?
Yes.
Therefore,
Yes.
Yes.
Yes, Miss.
Yes.
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 okay, the time is getting up. Let me summarize, and next time we will calculate, okay? We are supposed to calculate this thing, but the time is not enough. Let me sum up this. Therefore, if places have a longitude difference of 15 degree, then these places have an hour difference. If 2 places have only 1 degree difference, these 2 places have a 4 minutes difference. Therefore, this time differences, if you travel to the east of the prime meridian, is to be added. If you travel to the west of the prime meridian, is to be subtracted. For example, if you want to travel from Ethiopia to Japan, China, or Pakistan, or Philippines, calculating the longitudinal location, that time difference is going to be added on the time that you had when you were in Ethiopia. But if you travel to America or Canada or Brazil, then that time difference you have is to be subtracted. If they have 1 minute difference, then you subtract 4 if you travel to the west. If you travel to the east, you add that 4 minutes for 1 degree difference. For 15 degree, you add if you travel to the east, then you subtract if you travel to the west. And this thing is, or this world time zone is presented in this picture. You can see in how you add and you subtract. Here you have this 0 degree. Look to the 0 degree. Then from 0 degree, if you travel to the east, then you add it to the west, you subtract it. Then I will show you on how to calculate next time. For today, it's enough. But if you have a major question, very important, you can ask.
No.
Question?
No questions.
Okay.
Bye.
You want to ask a question? Okay, bye.
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 Miss.
Bye.
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 Hello.